Hi, welcome to my podcast. Today I'm going to discuss the need for static code analysis tools and their importance in software development cycle. More specifically, I will discuss the tool Cppcheck and identify its capabilities and limitations. The economics of software is such that the earlier in the development cycle a bug is found, the cheaper it is to fix. So it is a good investment to have static code analysis tools do the extra work to find problems rather than the debugger. But better a debugger find problems than an internal test group. The worst option of all is to leave the problems to be found by customers. Unfortunately, over the years, software engineers have learned this lesson the hard way. In the spring of 1993, the operating system development group at the company called Sunsoft were faced with a bug that held up the sale of $20 million worth of hardware. And the bug? It was just a typographical error. A programmer's finger had bounced off an equal key twice, and the intended assignment statement was converted to a comparison statement. Now, if that doesn't surprise you, here is a more catastrophic software failure. On the 4th of June 1996, an unmanned rocket named Ariane 5 exploded just 37 seconds after its takeoff. 2 weeks later, a board of inquiry submitted an investigation report. It turned out that the cause of the failure was a bad data typecast. The horizontal velocity of rocket, which was represented by a 64-bit floating point number, was converted to a 16-bit signed integer. After a few seconds into flight, this number was too large to fit into a 16-bit representation, and the rocket veered off its trajectory, causing the $500 million catastrophe. The computer world is a witness to many such mistakes in the past that could have been detected and rectified by use of software tools that cost, well, next to nothing. Static code analysis can reduce the post-release failures by over 50%, and thus cut development cost by 30%. Hence, the industry use of these tools has grown manyfold over the last 2 decades. The software defects can be roughly classified into 6 classes. Divide by zero, memory leaks, null pointer dereference, uninitialized variables, buffer overflows, and inappropriate data casts. Static code analysis today offers solutions for all or most of these defects. The good news is that many of these softwares are open source. One such software, which is also the topic of a project, is Cppcheck. Cppcheck is a static analysis tool for the C and C++ programming languages. It is designed to completely avoid false warnings. It uses simple control flow analysis with an assumption that all statements are reachable. For instance, it flags a warning on a buggy statement even if it is a part of the false block of an if statement. Cppcheck also detects and warns users of memory leaks. If it cannot find a memory deallocation corresponding to a previously allocated memory block, Cppcheck flags a memory leak to the user. It can also identify other defects such as array out of bounds, use of obsolete functions, use of uninitialized variables, and so on. While it is a useful piece of software, it lacks the advanced control flow analysis and does not identify defects accurately every time. For example, if a program has 2 independent if statements, one of them is true and the other one is false. Let's say the true if statement allocates a block of memory and the false if statement deallocates the same block of memory. This is a classic scenario for a memory leak. If you were to run Cppcheck on this code, it wouldn't flag any error. That is because Cppcheck is written around one fundamental assumption that all the statements are reachable. Hence, when it analyzes the code, it finds a memory deallocation that corresponds to a memory allocation to the same block, and the memory leak simply gets through undetected. Evidently, Cppcheck does detect many of these defects, but not all. It is an object of our project to study this open source tool, compare it with other tools, and evaluate its reliability. Today, static code analysis is key in controlling code quality even before unit testing. It doesn't replace other verification and validation steps, but helps remove certain defect types that otherwise wouldn't be found. I want to conclude this podcast with this rather pessimistic view of Edgar Dejatres. Program testing can be used to show the presence of bugs, but never to show their absence. Thank you. References to this podcast are Cppcheck designed by Daniel Marhamaki, Ensuring the Integrity of Embedded Software with Static Code Analysis by Ben Shelf of Coverity and Christoph Ebert of Vector, and a paper from IEEE software titled Static Code Analysis by Panagiotis Lourdes.